Hello students, how are you all? Today we will see how to prove the relation force equal to mass into acceleration. Yes, it's a very important relation. Force equal to mass into acceleration. We will derive this relation today. And to derive this relation, we will take the help of Newton's second law of motion. I want to repeat Newton's second law of motion. What is the law? According to Newton's second law of motion, the rate of change of momentum of an object is directly proportional to the force applied. Correct. If you apply force on an object, then the rate of change of its momentum is directly proportional to the force which you have applied. That is called Newton's second law of motion. We will take the help of this law to show force equal to mass into acceleration. Let's see. First of all, we'll consider that here is an object whose velocity is u. You are applying a force F. Understood? The body is already moving. M is the mass of that body. The body is already moving with velocity u. Now you are applying another force. What will happen? Its velocity will increase. Correct. So here its velocity has increased. Understood? That means u is less than v. Because this is final velocity, this is initial velocity. Final velocity is greater than initial velocity. Why? Because you have applied the force. So we can write that u is my initial velocity. V is my final velocity. Now if I ask you, what is the initial momentum? Initial momentum equal to mass into velocity. We know that momentum means mass into velocity. So initial momentum means mass into u. So mass into u, that is mu. What is my final momentum? Same way. Final momentum equal to mv. Yes, mv. So what is the change of momentum? Change of momentum is equal to final momentum minus initial momentum. That is change of momentum. That means mv minus mu. Final momentum minus initial momentum. Got it? Now, say you are applying the force which you have applied the force for the time t. Got it? The duration of the applied force is t. So if t is my time, then change of momentum is this. What is the rate of change of momentum? Rate of change of momentum equal to mv minus mu by t. Yes, this is the rate of change of momentum. According to Newton's second law of motion, this rate of change of momentum is directly proportional to this force. Yes. So force proportional mv minus mu by t. Got it? This is what Newton's second law says. Now, F proportional, I am taking common m. What I am getting? V minus u by t. Okay? F proportional m. I know that from equations of motion, we know that v minus u by t equal to a. V minus u by t is a. A is acceleration. Got it? V minus u by t means a. Fine. Now, if this proportional sign will convert into equal sign, equal, ma. But since we have converted this proportional sign into equal sign, so one constant will come, k. So we'll write k is constant. Got it? K is proportional constant. Now, if f equal to 1, m equal to 1, a equal to 1, okay, force is 1 unit, mass is 1 unit, acceleration is 1 unit, then let us put these values here. So instead of f, 1, k, m is 1, a is 1. So what we are getting? 1 equal to k into 1 into 1, that is k. So we got k is 1. The value of the constant is 1. Now use this equation. From this equation, f equal to k means 1. So we are writing 1, ma. So what we are getting? F equal to 1 into mm, a. So we got force equal to mass into acceleration. Got it? So by using Newton's second law of motion, and this is the way of showing that force equal to mass into acceleration. It's a very important relation which is required to solve numericals in physics. So what we have seen? We have seen force equal to mass into acceleration. Got it? Or we can also write that force equal to mass, acceleration means v minus u by t, v minus u by t. So you have to learn these two equations. Both the equations you have to learn so that you can apply both the equations in numerical of physics. Got it? This is my first equation and this is my second equation. Both the equation you should remember to solve the numericals of physics. Got? Thank you.